So today we are going to continue what we have been discussing last week. So last week, actually, I gave you very basic idea of the course, and then what we expect from you, especially what I expect from you in this during this course, during this module. So basically, so you have a lot of responsibilities towards the country, towards your family, and towards the society, basically. So today, let's get into the contents of the first set of slides that I've been shared with you. Right. So let me share the screen. Right, okay. Okay, so I explained you the learning outcomes and the course outline and the assessment, the reference books and all. So I hope you check the notes and the contents. So the first part today, so I'm going to talk about the brief history of programming. So first, these contents could be familiar to you. Maybe you have learned those things in your A-levels. So I'm going to give some of my perspectives on those things. And then we can, first, before programming, we have to learn how programming has become to the form that it is today, right? So in the early days, the programming was so different. And then like maybe 100 years ago, the computers were so different. The concept of computing is so different, right? So then based on that, the programming was different. But today, even small kids, they can do programming with different. So there are technologies that facilitates even the kids can program, right? So, for example, like today, before coming to this lecture, so I was in an examination duty for your seniors. So you're not ICT seniors, but BST and EGT, engineering technology. So they are doing, they had programmed in their second semester in C, right? So then I checked the exam paper, and then I realized in this semester, you all have to cover those things as well, right? So the programming is not, it is not something, a talent or some skill which is special, very specialized. So nowadays, like many other professions, for example, engineers. Most of the engineers, they learn program. In almost all engineering courses, they have program. And then the technology courses, they have program. Like BST, EGT students, so they learn program. And then especially like engineering technology students in our university, so they learn programming, even web program, web application even, right? So then as ICT students, it is an essential skill, right? So being ICT students, if you don't know programming, so that would be very awkward situation, right? Very, very strange. So all expect you to know programming. Okay. Right. So before that, let's see how the path of the evolution of program. Basically, not just programming, but we are going to talk about basically computing. How different ideas were changed over the time, and how so who are the people involved in those development, right? So if I go to the first written in a written history, the first person that we can consider as a programmer, right? So this is the person. He's called Hero of Alexandria. Right? His name is actually his name was not Hero. His name was Herman. So Herman was of Alexandria. Herman of Alexandria. So it is at the time it was it belongs to Alexandria is in Egypt. It belongs to the Greek Empire. So the Greek culture was there at the time, right? So then in Alexandria, so this person, Herod, right? So his name was Herod. That's what I was explaining. But the meaning of this in some languages, the Herod was the meaning of his name was toilet in some languages. Again, Heron කියලා කියන්නේ මේ toilet එකට කියන වචනයක් සමහර languages. Right? So in that case, his name was toilet of Alexandria in some languages. So it was kind of disgrace. So then he changed. He removed one of letters in his name, and then he changed it to Hero. Right. So now it is a nice name, right? And it is a meaningful name because we can consider him as a hero because he's an inventor, and we could say engineer, inventor, mathematician. He invented many new devices, many technologies, especially in Greek theater. Right? The Greek theater is a big scene at the time. Right? Like there were Greek tragedies and kind of Greek plays, right? So he invented a lot of new things. He introduced a lot of new ideas into the Greek theatre, right? One is including an entirely mechanical play, right? So it is a drama, but it is a mechanical play. The actors were puppets, right? Puppets. It's a puppet play basically, right? රූකඩ නාට්‍යයක් හැදුවා සම්පූර්ණ මේක can automatically run. Usually, like in puppet plays, so people have to control it, right? So there are people, they control those actors, puppets, right? But in this case, he invented a way to control them automatically. It's a mechanical play. So usually it was powered by binary light system. It's like a binary system, right? There were ropes, right? And then knots, and then cogwheels, right? So cylindrical cogwheels, and then ropes, and a lot of connections between them. Right? Then he could program his play. He could arrange those ropes and cogwheels in one way. So then it is a one play. And then he can rearrange those ropes and cogwheels in a different manner. So then it would be a different, right? So he could program the puppet show, right? So it is very, very interesting at the time. I mean, there was no such technology at the time, right? So people were amazed with his this automatic play, right? Then even in that play, so there were like sound of thunder, right? Some sound effects over there, right? So then they were produced by mechanically timed dropping of metal, right? So all those things were programmed, right? So what they had to do is nobody was controlling. Before the play, all the things were programmed, right? So then all of them could sit in front, and then they could the play would be puppet show would be played automatically, right? So that's the first time. I mean, in the recorded history, the programming was used as a concept, right? But I mean, some people say like maybe like 10,000 years ago there was this technology, and then for example, like in Sri Lanka, there was a King Ravana, and there were a lot of advanced technologies. So, however, we don't have any proof for those things. So that's the thing, right? So there are a lot of books, right? Like stories like Mahabharata, Ramayana, and all those things, but we don't have proofs for most of those things. For example, like for Ravana, there are no systematic proofs. Right? I'm not just telling that, but I asked from some of my colleagues and some people who are working in archaeology. So they said still like we are searching, but still no proofs. So then we have to accept. So Hero of Alexandria is the first programmer, the recorded from, right? Okay. Then we cannot find many things after that, right? So then, like we had the Greeks and the Roman Empire, and then in Europe mainly, and even in other areas like China and India, like the medieval times. Right? Those are very difficult times for the world, not only for regions, right? So then not much technology advancements during that time. But later on, in France, right? So this person, Jacquard, right? Joseph, I don't know how to pronounce French way, but his name is Jacquard, right? So he was a weaver and merchant. Weaver, ready, business karika, French weaver. So he created, he invented a new loom. Loom is the machine that creates those clothes, right? ලංකාවේ තියෙන අත්‍යන්ත්‍ර රෙදි කියලා කියන්නේ අර වියන රෙදි හරි. So he created a machine to do that, right? It is called Jacquard. The speciality of this machine is this machine again is was programmable. Still this machine is available, right? People they have created this Jacquard loom, and so if you check on YouTube, you can find how it works, right? So the most important thing is this Jacquard used punch card technique. So punch card is it is a metal board. There's a metal board. So there are several holes in that on that board, right? So you can change the pattern of that holes, right? So based on that pattern, you can create the clothes with one pattern. If you change that board to a different pattern, so then you can get a different pattern on a cloth, right? So if you want different patterns, what you have to do is just change the board, right? So based on that board, based on the patterns of that board, so we can get different pattern clothes. So it is programmable, right? Actually, this concept was used later in IBM, right? So that's how they input to the computers. Later computers, IBM computers, they use this technique to get inputs, like different program inputs, different instructions were given as punch card technology. It was used until maybe 50 years ago. Yeah, so until that time, it was there. More or less, it was there, right? So it is very important invention, right? Jacquard, right? The French weaver. So this mechanism played an important role in the development of other programmable machines, such as an early version of digital compiler used by IBM to develop the modern day computer. Right. So then we comes to the most important person, Charles Babbage. Definitely you have heard of this person. We consider him as the father of the computer, right? So why we call him father of the computer? Has he created a computer? To anyone? Did he create a computer?
No.
So then why we call him the father of the computer?
Because of the concept of abstract model of information.
Yeah, exactly. Like he only, as you said, thank you. As you said, he just designed a machine. He just designed a machine, right? Which is called analytical engine, right? He designed the machine, but he couldn't complete it. The story is like this. I mean, dramatize a story, right? The real story would be kind of, slightly different, but at the time, so he lived in UK, right? United Kingdom. At the time, Sri Lanka was under British rule, right? So we were in the same empire, right? So at the time, first he had an idea to create a machine which is called difference engine. Difference engine. Difference engine. So this machine, right? This machine can. So his idea was to develop a machine to do very simple calculations, like addition or subtraction, maybe, right? Only those operations. So then he had the idea. Then he went to the British Parliament, and then he asked for the money. Right? So I have this idea. Please give me money. Right? So then British Empire was kind of like they had a lot of things to do. Like it was very huge. Like India was under Britain, and then Sri Lanka and many other countries. So they had a lot of expenses as well. Right? So, but in the middle of that, they gave money for the difference engine. Right? So then the Babbage was working on that machine. Right? Then while working on that machine, he had a better idea. Right? So then he thought, okay, so not just addition or subtractions, but I can make a machine to do a lot of other operations. Right? So then he came up with the idea of analytical engine. Right? So then he stopped completing difference engine, and then he go to the British Parliament again. And actually, Charles Babbage, he was a noble man, right? Kind of rich man, but he didn't have enough money to spend on this. Right? So then he went to the Parliament again, and then he said, okay, I have a better idea. Then he explained that, and then give me money. So then they asked, did you make that previous machine? So then he said, no, but this is a better machine. So then they said, no, I mean, we gave you money, but you didn't complete your previous machine. If you're asking money, another funding, we cannot approve. They didn't give money, right? They didn't approve that money. So actually, like I consider Charles Babbage as a right, like really pure geek, right? Like so usually like geek or like, so whatever the things like the people who are doing computing with lot of fashion, like we call them geeks, right? Like so they come up with ideas and then they always try to do new things and so on. Like he's a pure geek person, right? So he had the design, right? He designed, but he didn't have money, so he couldn't complete this analytical engine, right? So his the initial idea was to do mathematical calculations. He wanted to do any mathematical calculation using this analytical engine. So he had a really good design, right? Perfect design, right? But he couldn't test it. Right? But later on, right, like after, so he did this maybe 1839 or 1840, around that time, right? So then later on, like 100 years passed, and then maybe like 1930s and 40s, around that time, right? People like engineers, they wanted to create his design, right? Actually, they then according to his design, they created analytical engine. Okay, and then it worked perfectly as he predicted, right? So that's the first idea of a mechanical computer, right? So that's why we call him the father of the computer. He designed that. Right? It was never built during his time due to the lack of funds from the British Parliament. Later, his design was built into a real machine and was able to work as he predicted. So this is, so I have given, so this is how it goes, right? Analytical engine. So then, like I emphasize, like he predicted, he wanted to perform mathematical calculations, right? His idea was that, right? So then later on, this fair lady, Ada Lovelace, like he came up with new ideas, right? So we consider her as the first programmer who wrote the first modern program, right? So however, based on the historical facts, analyzing those historical facts, some people, not some people, but most of the people argue that it is not correct. It is not 100% correct that she was the first program, right? But however, like because she's a lady, and then it is a kind of like grammatical to say that the first programmer is a woman, right? So that's why I mean, let's go with that idea. She was the first programmer, but historically it's not correct. So the Ada was again, she was kind of a high society, noble. She's from a noble family. Her father was a famous poet, Lord Byron, and then actually, like, he was kind of a noble person and kind of crazy person, like her father. So then her mother thought of teaching the daughter, Ada, some mathematics. So then he went to Charles Babbage. So Charles Babbage is not just an engineer, but he was a mathematician, very good mathematician. So then actually Ada was a student of Charles Babbage. Then Charles Babbage, so he explained about his analytical engine design to Ada Lovelace, and then Ada Lovelace, however, was the first person to see the potential or the capabilities of Charles Babbage analytical engine. Right. So Charles Babbage, so his initial idea was to use that for mathematical calculation. But Ada Lovelace, she said that analytical engine is more than that. Right. Not only for mathematical calculations, but it can do more. Right. So it can be used to, for example, to play music and many other things, solve complex problems, such as playing music. It is very complex, right? So she predicted analytical engine can do that. Actually, it was true. When and then the first program for the analytical engine was an algorithm to compute Bernoulli numbers, right? So that's the program that she added, right? Some people say it was done not by her, but someone else, maybe Babbage. However, she wrote a lot of things, a lot of predictions on analytical engines and its capabilities. That's the most important thing that Ada Lovelace did. So anyway, I don't have any problems that considering her as the first programmer. So I like that idea, right? So Ada Lovelace. Right. So then Herman Hollerith. So then he was the first. He started the IBM. Right. In 1896. Tabulating machine company, which later became IBM. And then in 1906, he developed a plug board, or we can say a control panel, that allows the machine to perform different tasks without reconstruction. So the early days, the first mechanical computers, so if you want to run one program, it has to be constructed in one way. If you want to do a different, if you want to execute different program, it has to be reconstructed. විදියකට කම්පියුටර් එක හදලා ඊට පස්සේ කම්පියුටර් එක ඇතුලේ වෙනස් කරන්න ඕනේ වෙන විදියකට ඒක රන් වෙන්න වෙන ප්‍රෝග්‍රෑම් එක. එහෙම නොකර එක කන්ට්‍රෝල් පැනල් එක නැත්නම් ප්ලග් බෝඩ් එකකින් වෙනස් කරන්න විදියක් හදුවා හර්මන් හොලර්. IBM එක පටන් ගත්තා මෙයා. One of the important figures in modern day computing. And then we go to the Alan Turing, right? So the Turing provided a very, very special idea. So the Turing machine, the concept of Turing machine. So we are using that idea, and it gave the birth to the modern computing. Right? So he's from British, actually, Britain again, British computer scientist, mathematician, and cryptanalyst. So if you have seen this movie, The Imitation Game, anyone seen this movie? Have you watched that movie? So if you haven't watched that movie, please watch that. It is very, very interesting, right? As like computing people, IT people, it is very interesting. So this is not about a Turing machine. This was about Enigma machine. So Enigma machine was used by Germans in the World War II. So during that time, so they used the Enigma machine to send messages, right? Like very, very important messages, encrypted messages from one camp to another camp, or from the base to some other camps. So they used this machine. It was very difficult to break that code. Enigma code. It was called Enigma code. It is very difficult. So then Turing was the person who did that. He could break the Enigma code, and then it was one important point to win the war against Germans. Right? So this the Imitation Game was the story of how he did that. Right? So then actually Alan Turing, the Enigma, breaking Enigma code, and then the Turing machine and Turing test. There's another concept in artificial intelligence. There's a concept called Turing test to check the AI applications. Right? And then Turing Prize. It is another, it is considered that Turing Prize is considered as the Nobel Prize of computing, right? Like it is the most prestigious prize for people in computing, Turing Prize. So every year it is given to the people who has done a lot of things in the computing and IT and telecommunication field. So I mean, if you read on Alan Turing, so there are a lot of interesting things. I recommend you to read and watch the movie, especially. Right?
Sir, excuse me.
Yeah.
Sir, who invented the Enigma machine?
Enigma machine, I'm not sure the person name. Like it was done by Germans, but I haven't found a name. Right? You can search. So there could be usually like in German inventions. So most of the their inventions are like it is a group, right? It is not just one person's work or something like. So I never. I mean, I never remember. I don't remember. I couldn't find any name. I don't remember any name. But you can search. So if you search, if you just Google Enigma machine, so then sometimes you may find some names. Right? So at the time, actually, like I'm going to explain some of those things. Like Germans were very advanced in engineering, technology, and then even in medicine. So they were very advanced at the time, right? So they wanted to be more, right? So that's what happened in the World War II, right? Otherwise, I mean, there are a lot of advancement, even in like philosophy. But there were a lot of German philosophers at the time, and then philosophy, and even in literature. So there are a lot of very, very advanced work in literature and music. So their culture and technologies, they were very advanced at the time. And but however, with the World War, some of those work were destroyed, unfortunately. But it is unknown. So please Google, and if you find a name, just share with the group, right? All right, so there's a name, right? So in the chat, so thank you, Samir, right? Thank you. In 1980, right? The first Enigma, right? So then, so if you check in if I have time, so I will share that. So you can check how Enigma machine work, right? So if you are interested in cryptography, right, it would be very interesting for you how Enigma machine was work. So there are some videos, animated videos. If I have time, so I will share LMS. Just check what Enigma machine was. But even if it is not directly related to this one, but as IT students, if you're curious, you have to check. Okay, right. And then please check Turing machine as well. Enigma machine, but Turing machine is what he has given to, I would say, towards programming, right? Turing machine, right? So he gave that concept how a modern computer can be created. And then this person, another unsung hero, I would say. He's from British Empire. So actually, he worked at British Post Office, right? So he was a telephone engineer at British Post Office. So that's how he was known at the time. But actually, he has created a special machine, which is called Colossus, right? During the World War II. In 1943, actually, he created that. It was the first programmable electronic computer, right? To help solve encrypted German messages. Right? So the Colossus used vacuum tubes to perform Boolean and counting operations. And actually, this machine was a secret until 1970s, mid-1970s. Nobody knew that this machine was existing. But then later on, people found out, and then they considered him as a hero. But until that, people knew him as just a regular engineer. So Colossus machine. I mean, here I have given a very few points, but there are many other people behind these things, right? Because of limited time, I don't have time to discuss all the things, all the people, and so on, right? But let's take some example figures. So that's the thing I'm doing here. Right? Okay. Then this is another person. He's German, right? He was German civil engineer, inventor, and computer pioneer. Konrad Zuse, right? So he designed the first algorithmic programming language, which is called Plan Calculus, right? So it can be translated as Plan Calculus, right? So it is considered as the first algorithmic programming language. I don't know much about that language. Sorry, if you ask anything about that language, I haven't learned or checked, right? Okay. So then John Backus. So John Backus, so he came later, so he born in 1924. And then he's an American computer scientist, worked at IBM. And then he's the first person who implemented Fortran language, which is considered as the first high-level programming language. So let's talk about high-level programming language later. So this would be the first high-level programming language, Fortran. So with Fortran, it changed the way that computers were used, dramatically changed. So it is. That's why we can consider him as a pioneer of modern programming languages, right? Right. John Backus, and then Dennis Ritchie, right? Another very important figure in programming. So again, he's from USA. He worked at Bell Labs. Bell Labs Computing Sciences Research Center. So he invented many things. One is C programming language. So he created C language, right? And then he developed Unix operating system with Ken Thompson. C and Unix, right? Without C and Unix, I don't think there would be something called modern computing or modern programming, right? C language gave the new perspectives to the to modern programming language. Most of the modern programming languages were created based on C. C දිහා බලාගෙන තමයි අනිත් programming ගොඩක් අලුත් programming languages හැදුවේ. C තමයි මුලින්ම ඒකට නිකන් මූල බීජය දැම්මේ. හරි? ඒතර C කියන්නේ C නැත්තම් ගොඩක් languages නැහැ. කියන්නේ C double plus, Java and Ruby, Python. I mean, now those languages are different, but C gave the idea of this modern way of programming. Most of the programming languages that we have today are C-based. And even to create new language, C language was used. And then C language was used to create operating systems. And many other systems, which are essential in modern computing. And then Unix operating system was the base of most of the modern operating systems. Linux, so Unix is still, so we are using Unix, right? In Sri Lankan universities, I have rarely seen Unix computers, but for example, like in Japan, where I have learned, so they have Unix. Most of the labs, they have Unix. Right? So it is very easy to work with Unix. You have to learn some things, but it is very, very easy, very powerful. Right? And then based on Unix, new operating systems were created, like Linux and then Apple OS, Mac, and then Windows. Those operating systems were built based on Unix. So he's a very important figure, but unfortunately, most of the people don't know him. Right? People know Steve Jobs, so they have created movies, at least 2 or 3 movies on Steve Jobs. What he has done was like he started Apple company, right? And then they created the operating systems and all. But without him, there won't be Windows, there won't be most of the modern languages, and then most of the modern operating systems. So, however, Dennis Ritchie died during the same week that Steve Jobs passed away. Right? Same week. But everyone was like beeping on that famous Steve Jobs, right? But nobody, I didn't hear much about Dennis Ritchie. People didn't care. But actually, without Dennis Ritchie, there won't be a Steve Jobs. So very important figure. And then, so I have given one of his books as our reference, right? This one, the C programming language, Brian Kernighan and Dennis Ritchie. Right. So he was the most important figures, right? Right. So I'm going to stop at this point. Right? There are many other people later on gave their lives for computing, right? But I would stop at this point, and we will learn about those people later on while we are learning new languages and so on. Right? But as I told you, there are many other people before Dennis Ritchie and after Dennis Ritchie. Right? I don't say like Steve Jobs is not important. He is very important. What he has done, but he has revolutionized modern computing, the modern devices. Right? Yes, we have to give him that respect, but there are some other people as well. We should give respect, maybe more than those famous people. Right. Right. So then, when it comes to programs, right? So usually, most of the people seek the programmers, maybe us, right, as like this, right? The users, right? So they see us as some aliens, special kind of people, right? Geeks, right? So, for example, like when I was studying for my master's in Japan, like that university was specialized for computing. Right? So only computer IT people were there at the university. So then there was a saying that the people from that university are kind of sometimes they call crazy, and sometimes they call like they are very strange. Right? So in that city, there was an idea that they are kind of different people, like aliens, like that. And however, like the programmers, they see users as like this. So medieval, like we don't know, like they don't know anything, right? So they are kind of very primitive. So you can see that, right? Like I mean, most of you will be working in software companies, right? If you go to that company, you will see that, right? Like because so in software companies there are two kind of people, like IT people and some other people, like in HR and then admin. So those people are there. You can see that difference if you go to the companies. HR people say like IT, that engineers are really crazy, and then IT people would say HR people, they don't know anything, they are so stupid and so on. Right? I have seen that. Right? So like I know people from both sides, like HR and admin and those area, and then engineers and IT people. So I have seen all those complaints from both sides, right? So, however, like basically we have an idea, like if software engineers or IT people, programmers, so those are kind of geeks. Those are like with the people with like very fat people with big bellies, and then they are kind of always working in front of computers, and they are geeks. They don't consider other things. They don't care about the world and everything. But it is changing. It is changing a lot, right? For example, like if you see these people, so these are kind of celebrities, right? All of them are celebrities. You can see like Jimmy Fallon from TV. He's a TV host, and then Carly Kloss, the girl here, like she's Victoria's Secret model. So we call Victoria's Secret angels, and then I don't remember the other girl's name. He's also from. He's a model. She's a model, and then Ashton Kutcher, and then I don't remember all of their names, and then a singer from Black Eyed Peas, right, the band, and then Tapsi Pannu, Hollywood actress, and then Ramesh Mahadevan, singer and Hollywood music composer, and then the corner down here, he used to like he was the Mr. Sri Lanka, right? So all of these people are some kind of programmers. For example, like Ramesh Mahadevan, he worked in a software company, maybe Oracle company he worked. And then Tapsi Pannu, he used to be a software engineer before taking acting career. Right? And then most of the other people, they are like computing people. Right? They involved in programming somehow. And then Mr. Sri Lanka, Brian Eustace Livera, right? He's a programmer, software engineer. Actually, he's one of my super junior, right? And so he was when he was in University of Moratuwa, like he used to play raga, and then he was a model, and then later he became Mr. Sri Lanka. But he's a very good programmer, right? So programmers are attractive people, right? So now that previously the images has been changed, right? It is a superpower of the contemporary world, right? Right. So so there's a question, right? So should we remember the brief history of programming for our semester exams? Right. Even last week, so I told you, right? Even last week I told you. So in your A levels, you learn for 2 years, maybe more than that, maybe 3 years, I don't know. So you learn focusing on the exam, right? You have been focusing on the exam, but in the university, right? So today is the second day of my in this module. So I want to say, I am not focusing on the exam. So don't come to my lecture focusing on the exam, right? Don't keep the exam here in your head and then participate. Like I am not targeting the exam. I am teaching programming, right? You should come to this lecture to learn programming, right? Then we are giving you assignments and exams just to check whether you have followed that, just to validate whether you have followed those things. Otherwise, this is not exam focused module or anything. Like all the other modules are like that, right? So don't worry about the exam. Just enjoy programming. So that's what I want you to do. So then if you do that, don't worry, you will pass the exams. So in exams, I just check whether you can write programs. That's all. Those things I would check. And then I would check whether you have the idea, the basic idea or basic concept of program. I would check those things. Otherwise, don't just try to remember all those things and everything. Right? So, if you really worry, so then you can check. You can find previous exam papers and check what kind of exam it was, and then what kind of questions I asked. Exam is not the important, the main concern in this module. Right? Exam is the least. Right? If you follow these things, if you learn, try to learn new things. Right? If I am repeating the things that you know, try to ask questions, try to explore more, try to learn new things. Right? ඉගෙන ගන්න lecture එකට exam එක ලියන්න ready වෙන්න lecture එකට එන්න එපා. ඒකට ready වෙන්න මේ lecture එකට නෑවිතුත් පුළුවන්. That's not the most important. Right? I want all of you to become good programmers. That's all. That's my. So, right. Any other questions? Okay, right. So anytime, like you can interrupt me anytime and you can ask questions, right? And the other thing is like time. I have to say a lot of things. Time to time, when I have time, when I remember, I tell those things. So you can interrupt me anytime and ask questions. Like, when you are doing A levels in school or in tuition classes, like the teachers, right? So they gave you a friend, right? So then you just try to work within that frame. And then you don't ask questions, right? Not much. Just if you follow the things that teacher says, so then you can pass the exam. But university is not like that. Like this is university, like Vishwavidyalaya, right? So you are exploring the knowledge. You are exploring the knowledge. You are creating the knowledge. In that case, you have to ask questions. You can question, right? And then from your questions, I would learn that. For example, like there's a very good question like who invented Enigma, right? I didn't know that, right? So then I learned that from you. It is not just like I am giving you and then I am and then you learn that. That's all. No, like we are exploring. So that's the thing. So you have to. I mean, if you have questions, definitely you should ask any type of questions. I don't say like if you ask questions, that's a stupid question. I don't say. I mean, definitely you ask stupid questions. Right? Sometimes you say, if I ask this question, people see me as a stupid person. I mean, this could be a ridiculous question, a stupid question. Right? Actually, stupid questions are the best questions. Those are the most important questions. Like, if I have learned some things in my life, I have learned them through asking stupid questions, right? Like always ask stupid questions. I really encourage you to ask stupid questions, right? If you think it is a stupid question, ask. Right? So that's the way to learn, right? We are exploring knowledge. Without exploring knowledge, I don't think we have a way forward. So ask questions, always ask questions. I am ready to ask questions. If you ask questions for 2 hours during this lecture, I don't mind, right? Because I mean, I am telling these things which are in the notes. That's not the way to learn. You can read it by yourself. Most of the things you would understand, right? Without my guidance. But if we can discuss the questions you have, the curious questions that you have, so that's where we can learn. Okay. So ask questions, anything related to the program. Like, I mean, if you ask questions regarding the degree program, where is the library, those things you can ask, but it would be kind of wasting the others' time because they have come here to learn programming. So if you can ask those questions some other time, I can give you time, but questions related to computing and programming, you can ask any type of question. Right? Okay. Right. So then let's go to the next part. So what is programming? right? So let's take some. Let's take your ideas on program. So, can anyone tell me what is program? As you understand what programming is. You can type, or you can unmute your mics, and you can just verbally you can answer. Yeah, so the way giving instructions to the computer. Because it, yes. It is the way or the mechanism giving instructions to the computer. Yes, exactly. Yeah. Any other answers? So there are like how many are there now? Like more than 120. So it could be different answers, different perspectives. So if it is in your A levels, so what you do is like, what is programming? You the usually teacher gives you a definition, then you remember that definition and you write it in your exams, right? So that's how you have done that. But in the university, we don't do that, right? Like people, like students, like we take your ideas, right? Yeah, okay. Answers are coming. Way user talks to the computer. Yeah, very good. Like how we communicate with computers. Yeah, programming is the bridge with the computer and human. Yes, exactly. Then writing code. So that's HANA, right? And then this writing code to be interpreted and executed by a computer or another electronic device. Yeah, writing code to be interpreted and executed by a computer. Yes, it is more a technical type of answer. Yes, it is correct. Exactly. And then process of giving instructions to a computer about how to perform a task. Exactly. Chandra, yes. And then computer programming is the process of performing a particular computation, usually by designing and building an executable computer program. Process of performing a particular computation. Yes, the process of performing a particular computation. Right. Programming is a way to instruct the computer to perform various tasks. Yes. It is a script for solving real-world problems. Yeah. Yes. Computer program consists of code that is executed by a computer. Yeah. So there are. I'm not going to read all the answers, but yes. Yeah. So let me say a way to say to computer what we want to do. Yeah. So it's a good answer. Yeah. Yeah, so there are many other similar answers, right? Keep typing, right? So, I mean, learning is not I am saying and you are listening. You have to come up with your definitions, right? Keep typing, right? I will look into them. And so basically, so that's the idea, right? Communicating with computer and giving instructions, the way of giving instructions to the computer. Right? So that's computing, so computer programming. In order to do that, so let's take a recipe, right? We all have worked with the recipes. I'm pretty sure, especially like the girls here, even boys. Nowadays, like, for example, like, I really like cooking, right? When I was in Japan, I used to, I mean, I learned how to cook, and then I used to cook for many friends, and then even in festivals I have cooked, and then I have in universities we had festivals, so I have cooked Sri Lankan curries and some Sri Lankan food, cutlets and those things. So, and then we used to sell them as like to earn some funds for some different organizations and so. And even I have worked in a restaurant as a part-time worker. And then like recipes are like very common these days. Right? Like if you want to cook something, what you have to do is just YouTube that, right? If you search it in YouTube, there would be a recipe how to do it. So recipe gives how to cook something, right? So then step by step, how to cook, right? So then in a recipe, there are two parts, mainly two parts. First, it will give the list of ingredients, and then how to use those ingredients to make something, the method, right? Ingredients and method, the steps, right? So give me 1 minute. Sorry for the interruption. So I was there are some other university work these days. Like we are very busy, so I had to take a call. Okay. So I was explaining recipe. Recipe has two parts: ingredients and methods. So method is the systematic process or the steps to make a particular food, right? For example, I have given a recipe for very simple a cup of tea, right? Sri Lanka, we can say like a Ceylon tea, right? So I think you all know how to make a cup of tea, right? So I have given the recipe. So if you see ingredients, 2 cups of water, 1 spoon of Ceylon tea or black tea, and 2 spoons of sugar. And then we can add, additionally, we can add, if you like, some milk, right? Milk powder or liquid milk. And then the method. Boil 2 cups of water, meanwhile add tea leaves into the teapot, and so on. Like we explain step by step, we explain what to do. Right. So here, most important thing is if you don't follow these steps as it is, if you mix up, right? If you do something like here, there are 4 steps. 1, 2, 3, 4. Boil 2, and then once water is boiled, and so on. Like we have 4 steps. If you do the 3rd step before the 1st step, so then you wouldn't get what you expect, right? So the important thing that we have to get here is you have to follow those steps one after the other. Right? There are some things. There are a few things that you can do. I mean, you can mix up, but most of the cases you have to follow them one after the other. Right? So that's the way that recipes are written. Right? In a similar manner, we write programs. Right? When we are writing a program, what we do is we are writing something like recipe. So similar to a tea recipe, a computer program presents a systematic set of instructions to achieve a specific task. Right? So here in the recipe, it is a systematic set of instructions to achieve something. To in this case, to achieve a cup of tea, to make a cup of tea. Right? In a computer program, we do the same thing. It's a systematic set of instructions given to the computer to achieve a specific task. Okay. So in the recipe, if you suppose if it is written in English, right? If you give it to someone in Sri Lanka, if you give it to someone in India, if you give it to someone in Poland, if you give it to someone in Japan, all of them follow that as it is, they will get the same cup of tea. In a similar manner, if you give a computer program to a Windows machine or to different machine, like sometimes the same operating system, different machine, right? In all of these machines, if you run that program, it will give the same result. If you run that, if your parents run that, if your girlfriend or boyfriend run that, it will give the same result. Right? So that's the importance of computer program. Right? Recipe එකක් වගේම තමයි. Recipe එක කවුරු හැදුවත් අන්තිමටම එන්නේ ඒ අදාළ අපි බලාපොරොත්තු වෙන තේ එක නම් තේ එක. මේ වගේ තමයි computer program එකේ output එක systematic විදියට දීලා තියෙන්නේ. ඒතර output එක සමාන වෙන්නේ. එහෙම නොවෙනවා නම් එතන බලන්න මොකක්ද ප්‍රශ්නේ. Right? And the other thing is it gives the data that the program needs and how to process those data to achieve the given task. Actually, what computer does is process data. Process data. Right? So processing data, we give instructions how to process those data. So that's a computer. That's a program. Right? What program does is it gives a set of instructions to process data. Can we data වලට මොනවද කරන්නේ කියලා instructions දෙන එක තමයි program එකකින් කරන්නේ. In a recipe gives instructions to do something or process ingredients. The ingredients අපි කියලා තියෙන ingredients වලට මෙන්න මේ දේවල් කරාම මෙන්න මෙහෙම අන්තිමටම මෙන්න මෙහෙම අපිට output එකක් ගන්න පුළුවන්. මෙන්න මේ දීලා තියෙන ingredients ටික මෙන්න මේ විදිහට කරාම අන්තිමට අපිට තේ එකක් හම්බ වෙනවා. තේ කෝප්පයක් හම්බ වෙනවා. අනේ මේ විදිහට මෙතන program making, computer program making කරන්නේ අපි මොනවා හරි තියෙන data process කරන්න instructions දෙනවා. මෙන්න මේ විදිහට ඔය data ටික process කරොත් මෙන්න මේ output එක හම්බ වෙනවා. අන්න ඔය instructions ටික දෙන්න තමයි computer program එකක් කියලා කියනවා. Simply, so that is what a computer program presents a systematic set of instructions to achieve a specific task or to process a set of data. Right. Simple as that. Okay, so we can elaborate that into this. So I got many answers from you, right? Computer program. I agree with you all, and then so these are some ideas from my side. Right? A computer program is a sequence of instructions to perform a specific task by the computer. These instructions should be given to the computer in a language that computer. That's where the problem is. So we all know, like we are giving instructions to the computer. The thing is, if computer cannot understand, that's the problem. The way computer understands, that's the problem. Right? For example, like we know, like to add these values, we know how to do that. Make that color, make that color, make කරාම හරි. කියලා අපි දන්නවා. හැබැයි ඔක කම්පියුටර් එකට දෙන්නේ නැහැ. අන්න එතන තමයි අපි මේ ඉගෙන ගන්න මොනවාද ප්‍රෝග්‍රෑමින් කියලා ඉගෙන ගන්න. How to give that in a way that computer understands. Right? So that's where the magic happens, right? And that's where the main problem is, right? Because machine, this computer, they don't understand our language. Right? So we are talking in Sinhala or in Tamil or English, whatever the language. This dumb computers, these dumb machines, they don't understand. Right? They only understand machine language, ones and zeros. Right? In modern, right, the latest computers, like in the quantum computers, like they have not just ones and zeros, some other possibilities as well. Like they don't use bits, so qubits. Right? But I'm not going to talk about those things now. But like usually, a computer understand only ones and zeros, like general computers that we are using now. Right? So there are two ways. The first way that you can give instructions to the computer is you have to learn machine language. You can give instructions the way that machine can understand in ones and zeros. So for example, this is one set of instructions. Suppose you want to give instructions to add two numbers, which are currently resides in register 1 and register 2. Right? So in processors, there are registers. Right? So suppose there are two registers, and there are two numbers on those registers. We want to add them and put the answer into register 6. Right? So it will be written in machine language like this. You can write it like this. මේ විදිහට ඒක ලියන්න පුළුවන්. හැබැයි මේක අපි කාටවත් තේරෙන්නේ නැහැ. හරි. මේක මතක තියාගෙන ඉන්නත් බෑ. දැන් මේ විදිහේ සීක්වන්ස් එකක් මතක තියාගෙන ඉන්න මේ 30කට වගේ සමහරට පුළුවන් ඇති. මේ 30 කිලෝවක් කියන්නේ කවුරු ජීනියස්. Genius කට්ටියට පිස්සෝ කියලා අපි සාමාන්‍ය කියන්නේ. එහෙමනේ. එද්දා මේ එම සාමාන්‍ය කෙනෙකුට මේක මතක තියාගන්න. හරි? But if you can give instruction in this way, that's fine. Right? But it is very difficult. But writing complicated programs would be very difficult. You have to write a lot of ones and zeros. Right? It is difficult. So the machine code for the same set of instructions in different type of machines would be different. That's the other thing. I'm giving instructions to this computer, and if it is a different computer with different architecture, so then the instructions would be different. The same program cannot be used. Right? We have to write a different program to that. But it is fine, like we can do that, but it is very difficult. Right? Right. So then, early stages of computer programming, they use machine language, but it was very difficult. So then they wanted to do better. So then they introduced assembly language. So in assembly language, right? So if we have a set of instructions, right? For example, one set of ones and zeros, right? They introduce some words, right? So for example, they invented words like add, or if it is multiplication, mul, moving, move, and so on, right? We call them mnemonics. Mnemonics. So here M silent. Huh? We don't sound M. Mnemonics. So instead of using binary numbers for instructions, assembly language uses short words that are known as mnemonics. So now we can write languages, right? Like these instructions in a simpler manner, simple way. However, that set of instructions, so these words cannot understand, cannot be understood by the machine. Machine still understands ones and zeros. Then what we need was a translator in between. So මැද translator කෙනෙක් ඉන්න ඕනේ මේ assembly language එකකින් ලියන program එක translate කරන්න machine language. We call it an assembler, right? So we write our program in assembly language. So then assembler again, it is a small program that we have created. That program, what it does is it translates this code into machine code, ones and zeros. Then that code, the translated code, can be executed by the computer. So we need a translator, we call assembler. Right. So then this is the second level of programming language. First machine language and then assembly language. You will learn assembly language in some of the other modules, right? So here we are not going to talk about machine assembly language, right? And then even this is better than machine language. However, if you want to give very I would say like very complicated instructions, then still it was difficult in assembly language. Assembly language again, complicated programs ලියන්න අමාරු. ගොඩාක් ලියන්න. ටිකට ලියන්න ඕන programs. Because of that reason, it was not very practical in when writing complicated programs. So then they went another step. They invented high-level languages. High-level languages, those are closer to our day-to-day languages, right? So Fortran was the first high-level language we learned earlier, right? In 1950s, high-level languages were introduced. So these new types of languages use words that are easy to understand. In addition, high-level languages provide the capability of writing powerful and complex programs without the knowledge of how CPU, right? However, if we use high-level languages, we need several levels of translating. First, high level into assembly, sometimes assembly into machine language. So anyway, if it is not the machine language, we need translators, right? So mainly we have two types of translator, compilers and interpreters, right? So today, actually, we don't have enough time to talk about all these things, but I know you already heard about these things, compiler and interpreter. But let's talk about those things in the next session. Actually, next session, so we are going to have that on Friday. So we are going to have our first practical session on Friday morning. Right? So let's talk about those things there. Right now, so that's all for today. So if you have questions, you can ask. So we have another maybe 5 minutes also. Less than 5 minutes. So if you have questions, I can answer. minutes. Otherwise, so you can go to the next lecture. So any questions? So if you don't have questions, so let's stop at this point. So let's meet on Friday, right? So until that, so stay safe and have a good day, and see you on Friday. Thank you very much.
Thank you.
Thank you, sir. Have a nice
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.